Hi, today we're gonna see the project of human activity recognition. In this project, we will be seeing what is human action recognition and how the computer vision can make this human activity recognition in applications. The major applications of this project can be in the healthcare, sports, smart homes, surveillances, and even in robotics. We will be leveraging the computer visions into this project, the improved deep learning models to face the challenges, to understand the challenges, and come with a robust implementation. The challenges can be the existing problems or the existing scenarios to be tackled. The problem statement of the current existing projects are the variation in the human movement and pauses. In order to identify the pause or the action, we need to train our dataset with large classes, and we often have the challenges of the image conditions such as lightnings, background colors, and etc. And most of the time, we have to do the manual feature engineering. And some of the existing systems which leverages the models such as Navy bias, Canon, and etc., which is used with the manual feature extraction. And the existing system often struggles with the real world conditions such as lighting, illusions, multiple objects, and etc. And even in the accuracy. So after seeing those all and after studying those all, we need to come up with an robust enough for the real-time detection or multi-purpose action recognition models, which can be at least approached to the real-world scenarios. Therefore, here our proposed system leverages the LSTM model, convolutional neural network, the long short-term memory model, which is gonna be utilized in our project, and it will be trained in the large dataset, which will have various classes such as walking, running, sitting, etc. The advantage of our model will be it need not to be having a manual feature engineering, rather it will have an automatic feature extraction, and it can overcome the noise of the image datasets and etc. And at the last, it will have a higher accuracy and efficient compared to the traditional models. Our system design will include the various phases such as the UI where the input will be given and the output will be taken, and the system diagram will be designed in such a way to give the accurate and higher efficiency while predicting the poses. The system diagram of CLSTM will contain many phases such as input layer, preprocessing layer, feature extraction layer, temporal modeling layer, classification layer, and output layer. So our methodology will have many phases such as data collection, where the data will be collected, the data set, and it will be given to the model. Before that, we will be pre-processing the data set by removing the noise and making it normalized and segmentation and etc. The feature extraction, the CNN layer extract the features automatically, and the sequence modeling LSTM layer captures the temporal dependencies in the activity sequence. It is going to study the image dataset into it. Finally, the classification, where the fully connected layer will study the dataset and understand the pattern of such as walking, running, sitting, standing, etc. Finally, the output visualization result will be displayed in the UI that we gonna make. At last, the conclusion. Here, as we can see, the model of our CLSTM has performed very well. As you can see, this diagonal pattern where the correct prediction happens, whereas the other boxes represents the misclassifications, which is minimal. And as you can see here, the classification report, the CLSTM model achieved about 83% of accuracy. Therefore, we can say that this computer vision system using this LSTM is giving good performance in order to classify between these various classes of actions. And here is the base paper that we have used. Here is the base paper, as you can see, a deep neural network for complex human activity recognition. This is the paper that we have referred to. And this is the code written in the Jupyter Notebook to train the data set, train the models, the CLST model with the data set which have about 5 classes, as you can see here: basketball, biking, driving, golf swing, and horse riding. These are the pre-processing codes and etc. As you go down, you'll be finding your model training part as well. Coming to the front end, you will be having your code, and once you start your program by saying python app.py, running this app.py file, you will be getting an IP address. If you go to this IP address, this will be the home page, or this will be the login page you will be landing on. So I'll be giving the credentials and login. Once you log in, this will be your landing page, the home page. As you can see, this home tab, and you will be having an upload button over here, or you can go to the direct tab also. If I click on it, upload, you will be having an option to upload the file, a video file, to analyze whether which action the person is working on. And as you can see in the graph tab, you will be seeing the training visualization of the model CLSTM, the classification report, the confusion report, the loss plot graph, and the accuracy plot graph. Finally, you're gonna see the change the password form. Once you can change your password over here, and finally you can log out. But coming back to the detect tab, and let us insert a sample and try it out. Here are various videos such as horse riding and running, standing, or fighting, everything. So now I'm gonna give the footage of fighting as it has been uploaded. Now if I click on it, it will go under process, and it says so. Coming to the detect tab, now I'm gonna be giving a video file to it to analyze which class or which action the human is performing in the video clip. I'll be taking this horse one and clicking. It is under process. Yes, it says horse riding. The video was about the horse riding. A woman was riding the horse, so the model predicted is as a horse riding with a confidence score of 99.8%. This is how the project is gonna work, and finally you can log out. Okay, so that's all from my side.